How to find sine, cosine, and tangent using special triangles. There are three main rules that we use in trigonometry. Sine of theta is equal to opposite divided by hypotenuse, cosine of theta is equal to adjacent divided by hypotenuse, and tangent of theta is equal to opposite divided by adjacent. Let's draw a right-angled triangle to show what opposite, hypotenuse, and adjacent look like. Let's call this angle theta. The side that's directly opposite this angle is called opposite. The side that's next to the angle but isn't the hypotenuse of the triangle is called adjacent. And the side that's opposite the right angle is called the hypotenuse. Sine of theta divided by cosine of theta is equal to tangent of theta. And this is another very important rule in trigonometry. Let's rewrite sine of theta as opposite divided by hypotenuse, and cosine of theta as adjacent divided by hypotenuse, and tangent of theta as opposite divided by adjacent. And to simplify this, you can cancel out divided by hypotenuse on the numerator and denominator. This simplifies to opposite divided by adjacent, which is equal to the right-hand side of this equation. And since the left-hand side is equal to the right-hand side, we have just proven that this rule is correct. And therefore, sine of theta divided by cosine of theta is equal to tangent of theta. Let's draw the first special triangle. And this is a right-angled isosceles triangle. And the two base angles are 45 degrees. And the sides are in the ratio of 1 to 1 to square root of 2. We can use Pythagoras' theorem to prove that the hypotenuse of this triangle is the square root of 2. In this equation, the A is 1, the B is 1, and the C is the hypotenuse. So we'll just write hypotenuse. So 1 squared plus 1 squared is equal to hypotenuse squared, and 1 squared plus 1 squared is equal to 2. So 2 equals to hypotenuse squared. And if you do the square root of both sides, you would get the hypotenuse is equal to the square root of 2. Let's rewrite our three trigonometry rules and say that theta is equal to 45 degrees. Sine of 45 is equal to opposite, which is 1, divided by hypotenuse, which is square root of 2. Cosine of 45 is equal to adjacent, which is 1, divided by hypotenuse, which is square root of 2. Tangent of 45 is equal to opposite, which is 1, divided by adjacent, which is 1, and this just simplifies to 1. Let's draw the second special triangle, which is a right-angled triangle, and the two other angles are 60 degrees and 30 degrees. The sides are in the ratio of 1 to square root of 3 to 2. Let's rewrite the three trigonometry rules, and let's say that theta is equal to 60. Sine of 60 is equal to opposite, which is square root of 3, divided by hypotenuse, which is 2. Cosine of 60 is equal to adjacent, which is 1, divided by hypotenuse, which is 2. Tangent of 60 is equal to opposite, which is the square root of 3, divided by adjacent, which is 1. And this can just be simplified as the square root of 3. Now let's say that theta is 30. Sine of 30 is equal to opposite, which is 1, divided by hypotenuse, which is 2. Cosine of 30 is equal to adjacent, which is the square root of 3, divided by hypotenuse, which is 2. Tangent of 30 is equal to opposite, which is 1, divided by adjacent, which is the square root of 3. And now we've learned how to find the sine, cosine, and tangent of 30, 60, and 45 degrees using special triangles.